All right, so today we're going to be looking at 7.2 hypothesis testing for the mean when sigma is known. So what we're going to be focusing on is actually rejection regions. We're going to save p-values for later. So I'm going to jump to page 15. So rejection regions and critical values. So another method to decide whether to reject the null hypothesis is to determine whether the standardized test statistic falls within a range of values called the rejection region of the sampling distribution. So by definition, a rejection region or critical region of the sampling distribution is the range of values for which the null hypothesis remember h sub 0 is not probable. Okay, if a test statistic falls in this region, then the null hypothesis is rejected. A critical value, z sub 0, separates the rejection region from the non-rejection region. So we have a couple of guidelines or steps. So first thing is we want to specify the level of significance alpha. Okay. Second, we're going to determine whether the test is left-tailed, right-tailed, or two-tailed. And remember, that's determined based off your alternative hypothesis. So if it's left-tailed, we're going to just simply find the z-score corresponds with alpha. If it's right-tailed, we're going to find the z-score that corresponds to an area of 1 minus alpha. And second or third one, if it's two-tailed, we're going to find the z-scores that correspond to the area 1/2 alpha and 1 minus half alpha. Okay. The nice thing about the two-tailed is they're going to be symmetric. Okay, so with that, you're going to have the positive and the negative values. All right, then our third step is we're going to sketch the standard normal distribution and then draw a vertical line at each critical value. and shade the rejection region. Okay. All right, so if we look at an example of this, if we want to find the critical value in the rejection region for a left-tailed test with alpha equaling 0.1, okay? So I'm actually going to go ahead and sketch this first. Okay. So we're looking at left-tailed test. And so I'm going to go ahead and shade this. This is our rejection region. And we know that alpha falls within the shaded region. Okay, so we need to find the critical value for 0.1. And this is actually going to always correspond to the same critical values as that bottom table, which would be 90%, which would give us a negative 1.645. So since it's 0.1, we're going to just assume it's negative because it's less than 50%. Okay. So the rejection region is going to be any z-scores less than negative 1.645. Okay, where that z-score is our standardized test statistic. So another method to decide whether to reject, and actually that little bit's the same as what we already talked about. All right, so using those rejection regions, okay, hold on one second, actually. All right, so this is a repeat as well. And so is this. So we're going to come back to that. All right, so we got two more examples of finding the critical value in the rejection region. We already did a left-tailed test, so we're not going to worry about this example. Actually, let's change this to be right. So a right-tailed test with alpha equaling 0.01. So I'm going to go ahead and sketch this. Since it's right-tailed, we're going to shade to the right. And we know that this area is going to be, I'm totally just screwing this up. All right, so this area for this alpha is 0.01, which because everything to the left would be 0.99 or 1 minus alpha. Okay. So if we want to find this critical value, okay, I'm going to look at our normal distribution. We know that when there's a confidence level of 99%, that area is 99 or 0.99. And so this is going to be positive 2.33. So our rejection region is when our standardized test statistic, Z, is greater than 2.33. Okay. We're going to save this two-tailed test to go over tomorrow as a class. And then something to note, anytime that a standardized test statistic falls within the rejection region, it's considered an unusual event. All right, so we have two decisions we can make. So depending on where that test statistic falls, we can either reject the null hypothesis, or we can fail to reject the null hypothesis. So remember, failing to reject the null hypothesis does not mean that you've accepted the null hypothesis as true. It simply means that there's not enough evidence to reject the null hypothesis. So we're going to go over these steps, and then we're going to save these two examples for tomorrow in class. All right, so the steps of using a hypothesis test. First thing, since we are using a z-test, we want to verify that sigma is known. The sample is random. and either the population is normally distributed or n is greater than or equal to 30. Okay. Our second step is that we want to state the claim mathematically and verbally. So we want to identify the null and alternative hypothesis. I'm just going to say we're going to state our H sub 0 and H sub A. Okay, remember, these are always complement to each other. Okay. Third, we want to identify our alpha. So that way on our fourth step, we can determine the critical values. We're going to do that from table 4. Okay. All right, after you've done that, step 5, we're going to sketch and determine the rejection region. Then we're going to find our standardized test statistic. Which is going to be z equals x bar minus mu over sigma divided by the square root of n. 7, we're going to make a decision. To reject or fail to reject the null hypothesis. And then lastly, we're going to interpret the decision with context to the original claim. Okay. So again, like I said, we're going to do these 2 examples together in class. So save that.